three types of loops or stitches possible in weft knitting: knit, tuck, and float. Let's take a look at the first one, the knit stitch. If every needle is fed a yarn and goes through the basic knitting cycle, the product is referred to as single jersey. All loops are knitted, and all loops look exactly alike. Look closely at this drawing of a regular knit loop. The length of yarn in that loop is called the stitch length. Notice how each loop has what can be identified as legs and a crown. The fabric at the left is technically the face side, and the stitches have an overall vertical appearance. On this side you see primarily legs rather than crown. The fabric at the right is technically the back, which takes on a horizontal appearance. In this view, you see mainly crowns. Referred to as a jersey stitch, stitches arranged in this pattern have a distinctly different look and feel from the face to the back. Another type of stitch is referred to as the tuck stitch, because one yarn is tucked behind another and hides. The pattern on the left shows the technical face for a tuck stitch. Follow the green shaded course of yarn across the pattern, and it looks like a loop has been tucked behind another. The pattern on the right shows the technical back for a tuck stitch. From the back, the tuck is more visible to the eye. How is a tuck stitch made? During the tuck cycle, at feed 1, the needle moves up from its rest position, and the old stitch that has been formed is held and not allowed to clear the latch. Yet the needle moves up far enough to grab a second yarn, which is put into a tuck position. Both yarns are then kept at the rest position. The knit cycle occurs with the next feed of yarn. At this time, both yarns are cleared. A new yarn is fed and pulled through both the held and tuck loops, forming a tuck stitch. The stress caused by holding one elongated stitch for an extra course causes more length shrinkage, but less in width than a regular knitted stitch. The tuck loop makes the fabric wider and thicker, and slightly less extensible. What is the overall structural effect of tucks on knits? Tuck stitches can give the fabric a cellular appearance. Some people refer to this as mesh. Tucks are the basis for piqué, typically used for golf and tennis shirts, which need to breathe, retain their shape, but have some stretch. A wide range of piqué constructions can be made depending on the use and frequency of tuck stitches. The third type of stitch is the float, which is also called a misstitch. The drawing on the left is a technical face. On the face, in the middle course of yarn and middle wale, it looks like the machine has hidden the colored yarn in the back. It is not captured or knit with any other stitch. This is the float or misstitch. On the technical back, you can see how the loop floats. To produce the float stitch, on feed 1, a yarn is laid to rest behind the hook of the needle. The needle remains at the rest position. It is not activated in the float cycle. In the knit cycle, it is. When a subsequent yarn is knit at the next feed, the missed yarn floats to the technical back of the fabric. Loops can be made to float over a series of wales. To make the structure secure, some float yarns can be tied into the ground with a jersey or tuck stitch. Float loops make the fabric more narrow and less extensible because the floated yarn is in a straight configuration. Why would you produce a structure with loops that float? Floats are useful for pattern effects, where some colors appear on the front and others are hidden on the back. This checkerboard pattern uses gray and white yarns. When the gray yarn knits, forming a gray square on the front, the white yarn floats to the back. If you turn the fabric over and inspect the back, the colors appear reversed. A second use is to create surface effects or change the performance of the fabric. You can make loops float on one side of the fabric, then nap them to produce a fleece. If not napped, these floats can be used for aesthetics or function. You've just seen how 3 stitch formations can be used in different ways. All can be produced on warp or weft machines, or used for single or double knits. Let's start by taking a look at the big picture, the basic configuration of most knitting machines. Commonly used for single knits are circular knitting machines, which pull their yarn supply from creels located either above the machine or next to the machine. To make it easier for technicians to service the creels, it is more usual to find creels located at the side. In this position, less lint falls into knitting elements. Larger packages can be used, and more feeds can be placed on the machine. Whether the creel is at the side or top, the principles for circular knitting are the same. Fed from above the knitting elements, yarns move from the yarn supply, or creel, through guides to stop-motion controls above the machine, then back down through tension controls and yarn feeding devices to the knitting elements. Quality products can be produced only when stop-motion and yarn feeding functions are properly set. The intricate action of knitting, where needles form loops, occurs at the middle of the machine, between the take-up and a close-up shows you how, with circular weft knitting, needles knit one after the other in a sequence for each yarn. Notice how loops are formed horizontally by needles knitting around the cylinder, forming a tube. After yarn is knit on the knitting elements, the knitted fabric is passed over a spreader mechanism through take-up rolls and is wound into a roll. This elliptical spreader distributes the take-up tension uniformly and enables the fabric to conform to a flat tube. In this segment, we describe how needles actually do their work. How are the needles arranged, and what causes them to move? Knitting machines are designed so that each needle can be placed in a groove, cut into the outside of a metal cylinder. Before we show you how these cylinders work, let's define the parts. The cuts or grooves may also be referred to as slots or tricks. The top edge of each groove is called the verge. These cylinders are very precisely manufactured, so the diameter measured at any place is equal. Machines are classified by the number of cuts per linear inch. This is referred to as the cut or gauge of the machine. For example, an 8-gauge machine has 8 cuts per inch. The total number of cuts around the circumference of the cylinder would indicate the number of needles in the cylinder. The more needles, the wider the fabric. Now let's take a closer look at the needle itself and label its parts. At the top of each needle is a hook. Below this is a latch, attached with a rivet. Notice that the bottom edge, or cup of the latch, is curved to fit over and completely close the hook. At the bottom of the needle is a butt, which plays a part in controlling how needles activate, up or down. A needle with a latch is very efficient. When the latch needles are used to create weft knits, the knitting cycle can be completed without any auxiliary attachments. Here's how the latch needle works. At rest, or running position, a knit loop rests above or on the latch. As the needle moves up, the old loop, already formed, drops below and clears the latch. As the needle moves down, it receives the new yarn to begin forming a new stitch. The latch is knocked over by the old loop, and this old loop is cast off. The needle moves further down to fully form and complete the new stitch. The amount of yarn used to form a new stitch determines the stitch length. This is important because stitch length affects the weight, width, and aesthetics of the fabric. On modern-day knitting machines, needles make millions of loops or stitches a day. Needles may need to be replaced due to wear, but they usually last up to 6 months, depending on construction, yarn type, fiber type, and speed. Next, let's take a look at what causes the needles to move up and down. In this illustration with a side view, You see how the butt of a needle guides the needle through a path formed by cams. Each cam is designed to allow the needle to run straight or to move up and down. Here's how the needle travels through various stages. At the rest or running position, the needle runs straight over the rest cam. When it hits the clearing cam, it rides up at a steep angle, which forces the needle to rise and clear the old loop. Then the needle drops when it contacts the stitch cam. As it continues on its path, it catches the new yarn. It continues further down, pulling the new yarn far enough for a new loop or stitch to form as the old loop is cast off. The up-throw cam returns the needle to its resting position so it can begin the cycle again. Take a look at this same action while the machine works. Watch how needles run through the camways, which cause the needles to rise and fall. And remember that this machine has a cylinder that contains vertical grooves and slots to hold the needles that move. As needle activation occurs, how does the machine control the movement of fabric as it knits? There's one more part, placed between each pair of needles, that you need to see to better understand this. It's called a sinker, and here's what it looks like. It's a thin steel element with a distinctive shape. This illustration highlights the parts. A sinker has a butt with a place to insert a cam. It has a hold, a throat, and a nose. As the needle goes up, the sinker moves in to catch the fabric in its throat. Since the fabric can't go up with the rising needle, the old loop now clears the latch. When the hook catches a feeder yarn as the needle moves down, the sinker moves back out of the way, and knockover, cast off, and stitch forming takes place. As the new stitch is formed, the fabric rests on the top of the nose. Here's one last view of needle activation to show you how knit fabric is formed. Knit fabrics can be made on more than one set of needles. Unlike single knit fabrics, double knit fabrics are produced from two sets of needles. You've seen how circular machines can be used to produce single knits, but they can also be set up to create double knits. To accomplish this, a second set of needles is arranged in a dial above the cylinder. This dial has slots that hold the needles at a right angle to the vertical cylinder needles. This illustration shows you how a circular knit machine has tricks in two places. In the cylinder below, and the circular dial just above. The dial has grooves cut in the outer perimeter in the same cut or gauge as the cylinder. Another view shows that the needles in the dial rest horizontally in their grooves. Also, there is a precise gap between the cylinder and dial. This distance is referred to as dial height. The dial height is important because it directly affects the stitch length, which controls physical parameters such as weight, width, thickness, strength, and hand. When double knit fabrics are produced, the knitting cycles of knit, tuck, and float are the same for the dial as they are for the cylinder. The needles in both the dial and cylinder have butts and are cam activated. Because two sets of needles are used, sinkers are not needed. As the yarns are knit and the fabric is formed, the tubular goods are removed to the inside of the cylinder, as with single knits. Another type of weft knitting machine, designed to make single and double knit fabrics, is a flatbed machine. These machines may have the two needle beds in the same plane, but usually they are set up in a V configuration and then referred to as V-bed machines. These knitting machines are used to produce tubular fabrics or flat panels that can be put together to form a garment. Because the width within a panel can be made to vary, this system minimizes waste and sewing. Also, the technology has matured so that a complete garment can be made on this machine. Here's how V-bed machines create the loops required to produce a double knit fabric. First, loops are at rest. Then both loops clear the latch. New yarn is received, and both loops are cast off as new stitches form. You may notice that these actions result in a fabric that is structured differently than a single knit. You've seen how weft knit fabrics can be made on either circular or V-bed machines with one or two sets of needles. Remember, when it's two sets of needles, we define it as double knit. A second type of gating, where needles are placed opposite each other, is interlock gating. This results in different performance. In interlock gating, cylinder and dial needles are spaced so they're directly opposed. To prevent needles from hitting each other during the knitting cycle, opposing needles are not selected at the same time. When needle 1 in the cylinder is knitting, the corresponding needle 1 in the dial must rest. This is achieved by the alternating needles in the dial and the cylinder never being activated at the same time. This requires two cam tracks for both needle beds. Therefore, the location of the butts on the needle shank must be in two positions. Most commonly used are butts in short and long configurations, as seen in this illustration. Needles with long and short butts are alternately arranged in the cylinder and also in the dial. During each feed or course of yarn, only half the needles are used. On course 1, only needles with long butt positions knit, those placed in odd positions of the cylinder and even positions of the dial. On the second course of yarn or feed, the short butt position needles knit, in even positions of the cylinder and in odd positions of the dial. 2 feeds are required to complete a full visual course of interlock knit, whereas in 1x1 rib knitting, only 1 feed is required to make a visible course. Look at the resulting structure of an interlock fabric. Follow one course across different wales, and you will see a complex knit. Remember that 2 feeds are required for 1 course of knit. This first colored yarn knits on odd dial and even cylinder needles. The second colored yarn knits on odd cylinder and even dial needles. Because loops interlock and alternate from the front to the back, the structure of interlock fabric is much more rigid and stable than that of a rib. At closer inspection, you can see that interlock is the meshing or interlocking of 2 1x1 rib courses. This prevents adjacent wales from having mobility. Different double knit constructions can be made on rib and interlock gated machines. Needle selection by mechanical and/or electronic systems, along with yarn selection, determines the design effect. A variation of an interlock knit can be used to produce a structure that is tight and stable, where one course of fabric is attached and interlocked while the next is not. Ponte di Roma, used for women's dresses and suits, is an example of this. This fabric has the same appearance on both sides. Here's the notation for this type of fabric. During the first two feeds, the machine knits interlock. With the third feed, the machine knits jersey on only the cylinder needles. At feed 4, jersey is knit on only the dial needles. It takes 4 yarn feeds to make 2 visual courses. Although it is smooth, Ponte di Roma has a slight horizontal rib appearance and is thicker and more stable than interlock. Whether circular knit or flatbed machines are used to produce double knits, there is some variance in how needles are employed to create this fabric. Both sets of needles can be used at the same time or at different times, but they don't touch or hit. How are they positioned and activated to accomplish this? On a knitting machine, needles are gated or spaced in the dial and the cylinder in relationship to each other. With rib gating, the 2 sets of needles are not directly opposite each other. The needles of the cylinder are between the needles of the dial. Here you can see how both sets of needles can knit at the same time without touching or hitting each other. Although all needles have the same length, the butts are in 2 different locations, which activates the needles to create patterning. Rib gating results in a fabric where face loops and back loops alternate in the same course. A face wale is made by needles on the cylinder. A back wale is made by needles on the dial. Look closely at the structure of the fabric, and you see that a vertical line or wale of visible crowns is arranged between 2 vertical lines of visible legs. This construction is 1-by-1 rib, where both sides of the fabric look the same. There are different notation systems for needle selection. This example shows how knit loops alternate 1-by-1 on dial and cylinder needles. This notation is for a 1-by-1 rib. Notice that both long butt and short butt needles are selected. This notation is for a 2-by-2 rib. Here you see that for each feed of yarn, 2 loops produced on the dial are alternated with 2 loops produced by the cylinder. Note that with this configuration, only needles of long butt positions knit, while the needles with short butt positions do not knit. Because basic rib knits have alternation of face and back wales, the structure can easily be stretched. In the normal relaxed state, the back wales hide behind the face wales. When stretched in the width, the structure opens like an accordion, resulting in more stretch than single knits and other double knits. The back wales now become visible. When pulled in the length direction, the back wales move behind the face wales and the fabric becomes more narrow. Because of this extensibility, basic ribs are used for sweaters and dresses, as well as for neck collars, arm and waistbands. We've just shown you 2 of the simplest rib-gated double knits. Another commonly used construction for rib-gated double knits is Swiss piqué. Its structure is a bit more complicated. This notation shows you the pattern for knitting on the cylinder below and the dial on top. With feed 1 of yarn, the machine knits on all the cylinder needles, but on the dial, the machine uses only the needles with long butt positions. With feed 2, it misses all the cylinder needles and knits only the dial needles with butts in the long position. With feed 3, the machine knits with all the needles on the cylinder, but only with the dial needles that have butts in the short position. With feed 4, the machine knits only on the dial needles with short butt positions. The Swiss piqué produced from this needle pattern has a distinctive texture and appearance. The fabric produced has good stability and does not curl.
My name is Marco Andrioli, and I am the technical manager of Santoni. I'm pleased to introduce the circular machine with the finest gauge ever built in the world. The machine makes the stitch without using the sinkers, but only by using the needles with the support of the cylinder's edge. A special mobile holding down jack, Santoni's patent, is inserted only to unload the loop when the needle begins to rise again, and moves away when the needle descends to pick the yarn. The cylinder 30-inch, which in the loop formation area has as many as 8,472 spaces and is covered by a Santoni patent. A needle thickness of 0.18 millimeters, never before realized by Grotz-Beckert, is used. The Atlas system prevents the fabric defects often caused by the sinker, vertical lines, irregular stitches, etc. A very clear problem with extreme gauges. In the traditional jersey stitch, the sinker movement, which is needed to facilitate the stitch production, exerts considerable stress on the stitch, with an ensuing oversizing of the loops. In contrast, the stitch made with the Atlas system is narrower and more compact, just because of the absence of such an obstacle. A shorter length of stitch means greater dimensional stability right on the loop formation. To get a certain weight, the possibility to use thinner yarns with respect to traditional machines. All to the benefit of the fabric's quality and its look and feel. Lower dimensional adjustment after production. The cooperation between Santoni and the Technology and Development Center, TEZ, has allowed Grotz-Beckert to develop and build the textile parts, needles, holding down jacks, cylinder, for the loop formation. The holding down jack is made with high precision because in its working phase it has to contain 2 needles. The needle guide function is carried out by the lower part of the holding down jack, which causes, in case of possible swings, the displacement of both elements with resulting lack of shocks. The system studied by Santoni in collaboration with Grotz-Beckert does not cause friction between needle and holding down jack in the yarn's running area. This condition leads to very long needle service life. The Atlas works with very low yarn tensions, made possible by the use of the holding down jack in the loop formation process. The low yarn tension causes decidedly low stress on latches. This possibility is very useful with very fine gauges when latches are very thin. The yarn sliding on sinkers in traditional machines leads to bad positioning of the yarns on the knitting platform, with resulting plating defects. The Atlas has proved to be free from this knitting defect, thanks to the fact that after yarn insertion and completion of the loop formation, the yarn does not come into contact with any other element apart from the cylinder. Only after loop formation and stabilization does the holding down jack come into contact with the yarn. In the event of a restart, the holding down jack's presence avoids stitch build-up on the needles, thus preventing breakage. This system, patented by Santoni, offers clear advantages in terms of energy consumption and heating of the textile head. In this gauge, the total friction force applied to the needles is approximately 40% lower than that of a machine with a traditional cylinder. The cooperation between Santoni and the Grotz-Beckert Technology and Development Center enabled us to realize this ambitious technological development. The excellent results are making us consider new projects together with the Grotz-Beckert Technology and Development Center.
Ini adalah mesin Jingmei yang sudah ada di Indonesia. Ada beberapa tipe: single jersey standar, single jersey open weight, single jersey body size dengan high speed sampai 40 rpm, single jersey terry mesin, single jersey fleece mesin. Berikutnya double jersey mesin. Double jersey mesin yang ada di Indonesia saat ini adalah jersey tipe GT yang standar dan GT tipe open weight. Di Indonesia juga terdapat mesin Jingmei double jersey single jacket, dan juga ada GT high speed body size. Untuk yang sistem computerized ini memang ada dua tipe. Tipenya satu double jersey single jacket dan double jersey double jacket. Sementara di Indonesia baru terpasang double jersey single jacket, dan kemungkinan untuk tahun-tahun ini kita juga akan masuk mesin double jersey single jacket dengan cara kerja two way dan three way. Selanjutnya